All right. Chapter 1 is all on elections, but we're not going to just pick a winner. Instead of doing regular elections where you just pick who you want to win, you're going to have to label things from first place to last place. Okay. So first things first, we need 3 things for an election. First off, we need voters. What are voters? People. Okay. These are the people that vote or participate. Okay. You need people to give you their opinion. The second thing you need to have an election are candidates. What are your candidates? The people you vote for or your runners. I guess we should put or things because we're not always going to talk about people. We're going to rank things. And what about a ballot? That's what you vote with. Okay. How voters express their opinion. How many of you have actually gotten to vote in an election yet? Everybody else is still waiting for the 18 and the next lovely election. Okay, so like I said, you're not just picking who you want to win in this chapter. We're going to do things by preference. So we're going to cast what we call preference ballots. Okay, and a preference ballot is when candidates are ranked. So you're picking somebody to be in first place, second place, third place, so on and so forth, depending on how many people you have running. Okay. The biggest thing with your preference ballot, you can't have a tie. You can't say, oh, I like Ashley and Kimberly the same, so I'm going to put them both in first place. No, one has to come before the other. Okay. So when you cast your ballots, they're going to look something like this at the top. Okay, so this would be Ashley's, this would be Kimberly's vote, this would be Cozy's vote, so on and so forth. Each one of these is somebody's preference. Okay, so Ashley went and voted A first, B came in second, C came in third, D came in fourth. Okay, this looks like a mess. So what we do is we combine things and we create what we call a preference schedule. So a preference schedule, by definition, is grouping identical ballots. Into a simplified table. Total voters is equal to the number of ballots. And each column is going to be what we call a distinct ballot. This is actually going to be one of the first processes of your project for this chapter when you go to do it. We'll talk about that when you go to take your first quiz. That way you can start. It's the first time you actually understand something in math class?
No, it's just because last math we didn't have much, and then my last semester classes we didn't really do much either. So.
Oh. This is the first time you've actually been taught all year? Oh my goodness. I got it. All right. Are there any questions so far with anything we've done? Please, if you get confused, I need you to be like, look, when we talk about this again, do not get yourself lost. Okay. All right. So if you take a look at the first preference ballot, we put A first, B second, C third, and D fourth. How many people voted that same exact way? So there was one of them.
The third one.
Okay, there's 2. We've got 3, 4, 5, 6, and 7. So above that column, you're going to put 7. So instead of having 7 of the same thing side by side, we're going to condense it and make one column and just put a 7 above it. So that tells you that 7 people put A first, B second, C third, D fourth. Okay, that's what we're going to do with the rest of these. So my next one in is BDCA. And we've got 1, 2, 3. So a 3 at the top of that one. And then we've got CB, bless you, DA, 1, 2, 3, 4, 5 of them. And we've got one lonely ballot all by itself, DCBA. It's a lot easier to look at just 4 columns than 16 columns side by side. Bless you. We're allergic to math class already. Okay, so you're going to have to take ballots and make a preference schedule. You're then going to be able to answer questions about the preference schedule. So the first question says, how many voters are in this preference schedule? 16. If you have 7 that voted in the first column, 3 in the second column, 5 in the third column, and 1 in the last column, gives you 16. Each column in your preference schedule looks different, which means that they are distinct. So that's the distinct ballots that you have. How many different columns? So this one is different than this one, which is different than this one, which is different than this one. So you should have 4 distinct ballots. Which candidate received the most third place votes? C. How many votes do they have for third place? No. Think about the numbers that you put at the top. Okay, so C came in third here and here. So that's 7 and 3. So C has 10 votes for third place. Okay. That's the biggest thing that everybody messes up with this chapter is you've got to make sure that you're paying attention to the numbers at the top. It's not how many times, it's how many voters put them there. So C has 10, D would have 5, and B would have 1, which means yes, C has the most third place votes. And so please be very cautious of that. Which candidate received the least second place votes? That one is going to be C as well. So if you look at your second place, B came in second place in this column, which gives them a total of 12. D came in the second column, which gives them 3. And C came in the last column, which gives them 1. You're fine. I'm going to go back over those last two. You're fine. Don't ever be afraid to ask me to go back over things. So if you look at this third column here, C gets its points from this column and this column. Okay. So 7 people put C in third place and 3 people put C in third place. So that gives them a total of 10 points. Does that make sense? Okay. D took this column, 5 people put them in third place, and B takes this column, 1 person put them. So C has the most. Same thing with the second place, except you're going for the least amount of votes. Anybody else? Questions, issues, something you want me to go back over? Okay. So here's another one for you. Come on. Okay. They want to know how many candidates are there. Remember, candidates are who we vote for or what we vote for. There are 5. Okay. Your candidates are your red, blue, pink, yellow, and green. Okay. How many voters are represented? 26. Again, you get that from adding up the total at the top. So 6, 8, 4, 3, and 5. And how many distinct ballots do I have? 5. We've got 5 columns, so 5 distinct ballots. Who has the most first place votes? Red. Red has 10. Okay. Red has 10 because they took this first column and they took this middle column. Who has the least first place votes? Green with 3. Perfect. Which candidate got the most last place votes? Green with 8. And who has the least last place votes? Red with 3. Question. So there's some important things that you need to remember about preference ballots. First off, they're transitive. So the definition says if A is preferred to B and B is preferred to C, then A is preferred to C. So in other words, if I like basketball over football and football over soccer, then obviously I like basketball over soccer. Okay. Whatever I have ranked first, I like more than anything. Consider the ballot of 5 sports. Which sport did voters prefer more? Football or baseball? Football. Football comes in second place. So, and baseball comes in fifth. So this is going to be football. What's preferred more, soccer or basketball?
Basketball.
Basketball. Basketball is in first place slot and soccer's in third. You're fine. You're fine. Okay. Last thing. If I have to eliminate a candidate, so if I take soccer out of the equation and we're not looking at soccer anymore, the rankings don't change per se. Everything just shifts up. So if I take out soccer, that means first place is now basketball. Second place is now football. So those ones didn't change at all. Hockey now goes up into third place. And baseball now goes up into fourth place. So I don't change the order of what everything goes in. Everything just shifts up. One place or two places, depending on whether you're eliminating one candidate or two. Any questions on what we just did there? One more example on this section, and then I'm going to teach you the first way to find a winner, and we are finished for notes for today. Okay, they want us to make a preference schedule out of so we just got to get used to doing them now and make it easier on ourselves. So a political convention has 1,500 voting delegates choosing among three possible party platforms. You've got liberal, moderate, and conservative. 17% of the delegates prefer L to M and M to C. 32% like C the most and L the least, and the rest like M the most and C the least. Write out the preference schedule. So pull it apart piece by piece. The first thing they tell us is 17% prefer L to M and M to C. So what does my column look like when I create my schedule? LMC. Now I got to figure out what number of voters I can put at the top because you don't want it in percent. They tell you we have 1,500 voters. How do I find 17% of 1,500? Yes. Okay, so I've got 1,500 total people multiplied by 17% written as a decimal. So you would multiply that by 0.17, and that should give you 255. Okay. My second column goes off of 32%, like C the most and L the least. So that column looks like CML. C's the most, so it goes in first place. L's the least, so M fills in the middle. Same idea, 32% of 1,500. And that's going to give us 480. Perfect. My last column then. The rest like M the most and C the least. MLC. We have two options to figure out how many voters we need in that last spot. Okay. I can either take this grand total and subtract off the first two columns to figure out how much I have left, or I can figure out what percent I have left and multiply like I did before. So this last column should be 765. And again, if you need to see the math, 1,500 minus 255 minus 480 will give you your 765. Bless you. Okay, exploratory question. If I have 3 candidates in an election, is there a maximum number of columns that the preference schedule can have? If yes, what is that maximum number? So I'm going to tell you this. First off, it's yes. Let's see if we can come up with that magical number. So if I have 3 candidates, one of my columns could be ABC. What else could I have? ACB. BCA. BAC. CBA. And CAB. Is there any more combinations I can have? No. So there's a total of 6. Okay. The way that they find that is a mathematical equation called factorial. So I have 3 candidates, and if I factorialize that, which is an exclamation point in that class, and what this tells you to do is it tells you to start at the number 3 and multiply it by every number below it. So 3 times 2 times 1, there are 6 that you can have. If I up that to 4 candidates, that becomes 4 factorial, which is 4 times 3 times 2 times 1. There are 12 different columns you can have. So that gets bigger and bigger with every candidate that we add in. Any questions on preference schedule? All right, let's talk about your first method. So your first method is called the plurality method, or what I like to call the popular contest. Okay, this is your popular contest. Which truly means most first place votes win. So when you're trying to find a winner with the plurality method, you don't care about anything that comes after first place. It's there, but you don't need it. It's useless information. Okay? All you care about is this top row. So if you look at the top row, how many first place votes did candidate A have?
14.
14. They took that first column, so a total of 14. B has 4. Perfect. C has 11. Okay, be careful. C comes in first here. Whoa. Welcome to my board. Doesn't like me ever. No. All right. We'll roll with it. So C comes in first in that second column and the fifth column, which gives them a total of 11, and D will have 8. So if they ask you, who's your plurality method winner? You would tell me A. So that's this question. Just because a candidate wins plurality does not mean that they also have the majority of the votes. Okay, so by definition, majority means that you have greater than half. Okay, not half, you have to have more than half. So, in order to have a majority, I need half of the votes. So to figure out what that number is, the first thing I need to do is get the total amount of votes. How many people voted in this election? 37. So if I half that, what does that give me? 18.5. So, in other words, you need 19 votes to also have the majority. So, even though A won plurality, they only won with 14 votes. So, they are not the majority winner. Okay, they do not have enough votes to be the majority winner. And that's okay, they still won. But it also gives you that boost when you've got more than half the people that actually like you. And then we could go back to the lovely Trump election where Hillary actually had majority votes and still lost.
It's so funny. It's looks for us.
Yeah. Question. All right. Let's look at this one. What is the total number of voters in this preference schedule? How many people voted in this preference schedule?
64.
20, 30, 40, 50, 66. Okay. So 66 people voted altogether in this election. So how many votes do I need to have a majority of the votes? 34. Okay, again, greater than half. So when I cut 66 in half, whoops, that gives me 33, and you need more than that. So I need to round that up to 34. Okay. Which candidate is your plurality method winner?
Big 10.
SEC.
Big 10. No, wait,
SEC.
We apparently are between Big Ten and SEC.
SEC is 20.
SEC is actually going to take this. So SEC has 12 here and 20 here, which gives them 32. Big Ten takes this column and this column, which only gives them 26. Okay. So this one's actually going to go to SEC. And we said that they had 32. Do they also have majority?
No.
No. I told you it's not that bad. Everybody dreads this class because I give a lot of projects. It's really not that bad. I'm good until we get to sequence and series, and then y'all like hate my life. All right, so consider an election of 40 voters. What's the smallest number of votes that you need to be a majority candidate? 21. Okay, again, when we cut that in half, that gives me 20, so I need 21 votes to win majority. If I have 4 candidates, what's the smallest number of votes that you could win plurality?
12.
I agree with 11. He said 11. How did you get 11?
Because if you divide, If you divide 40 by 4, you get 10 each in majority.
Perfect. Okay, so if I have 4 candidates and 40 voters, each of them could all tie with 10 votes. To give somebody that push to win, you would need 11. Because once you hit 11, nobody can tie you. They can't all match you. What if there's 5 candidates? What's the smallest number of votes that you need? What's 40 divided by 5? It's going to be 9. Good. This gives you 8, so everybody could tie with 8. So to give you that extra advantage, you need that 9th vote. So make sure you always give them that extra shove when it comes out to be a whole number. This is it, last page, friends. Actually, try this one on your own before we go over it. Same idea that we just did with the 40. Right? So if I have 15 voters, what's the smallest number of votes needed to be a majority candidate? 8. Again, 15 divided by 2 gives me 7.5, which will give me, I need 8 to take majority. If I have 3 candidates, what's the smallest number that a plurality candidate could have? 6. 15 divided by 3 makes everybody tie at 5, so we need that push. And what if there are 4 candidates? 4. Fantastic. Questions? Okay. In order for an election to be fair, it needs to cover 4 fairness criterions. We're only going to talk about the first one today. It says, if candidate X has a majority of the first place votes, then they should be the winner. Well, if you've got more than half of the first place votes, you should be the winner. Unfortunately, you have seen that that does not always happen. I think we've had 2 elections now where the majority candidate has lost because of the Electoral College. Okay. The plurality method satisfies this criterion. So as of right now, the plurality method is fair. Once we get into some other criterions, it may not be fair anymore. Last example. A 100-member marching band has been invited to 5 different bowl games. The Rose Bowl, the Cotton Bowl, the Hula Bowl, the Sugar Bowl, and the Orange Bowl. If you are not aware of these are college football. Okay. Using the plurality method, at which bowl game will the marching band perform? Where are we going? Who's your winner?
Rose Bowl.
The Rose Bowl. The Rose Bowl has 49. Does this seem like a good representation of where the marching band really wanted to go?
No.
Why?
Because it has less. It's really less. R is 48.
Look where R falls in this second column and this third column. Dead last. There's more people that did not want to go to the Rose Bowl than there were that wanted to. Okay, so you had more people. Whoops, if I can spell today. Holy cow. More people disliked the Rose Bowl than liked. This falls under the insincere or strategic voting. Okay, you will find this a lot once you become actual voters. Okay, normally we've got 2 parties. We've got the Republicans and the Democrats. And then you've got some, independent people that like to jump in there and see if they can win. Well, even though you may like that independent person a lot and you really, really want them to win, most of the time you don't pick them. Why? Because they don't stand a chance, because nobody else is going to vote for them. So, insincere voting is when if your candidate has no chance to win. So you vote for a lesser choice with a better chance. So your vote's really not going where you want it to go. You're just picking the lesser of 2 evils. Any questions? Anything you want me to go back over? Okay. So at this point, I need you to get on Canvas. You'll, under the Chapter 1 tab, you'll see something called Chapter 1 book pages, and you're doing numbers 1 through 6. 1 through 6.